Unit testing can be tricky. While most of the time our requirements map very well to assertions and individual test cases, there is also the other side of the coin. There are times where our data structures contain fields that are not so easily and not so obviously testable, especially in case of one topic that has always been error prone throughout all of the computer programming history: dates and times. Hello and welcome to my channel. My name is Marcin and I'm a software developer that works mainly in Java. In this channel, I will be sharing with you useful tips, tricks and code snippets that actually help me in my computer career and in various projects. Today, we'll look at asserting the current date and time in a JUnit test, which might sound a bit complicated, but in reality is very easy provided we use the correct tools. And, which is very good for us, the correct tools are already bundled with our standard Java development kit. Let's go! For this exercise, let's consider a simple weather service where the users can call the predict method to get a weather forecast. The forecast is very simple. It includes a human readable description of the weather, as well as the date and time at which the weather was predicted. And for the purposes of our tests, we want to check if the predicted at field of the forecast really is set to the current date and time of the service. So here's our test, and let's start with creating a test method. Let's call it includes the forecast date and time. And like always, we start with instantiating our weather service. And let's get our forecast. We'll call the variable actual. And now let's think about how can we check the predicted at field of the forecast. Well, one thing we cannot do is we cannot just assert that our actual predicted at is equal to offset date time now. And the reason why we can't do this is because while the test is running, the system clock is ticking, and this time will never be equal to the exact time where the weather forecast was constructed. Let's check it. And like we see, the difference is in the milliseconds, but is equal to just checks the object using equals, so this approach won't do. What we can do is we could define 2 points in time. One would be the start time, and the second would be the end time. And with these 2 points, we could check if our predicted at date, first of all, is after the start time, and at the same time is before the end time. And this approach will give us good results because from the code we see that the construction of the object is in fact between these 2 times. But there is another way that we can do this, and this way utilizes the clock from Java. For this, we need to inject a clock to our weather service. So let's do this. Clock, and let's generate the constructor. And now our new forecast will use the clock while checking the current date and time. So with the reference to the clock in the offset datetime now method call, the now method will use the clock to determine the current date and time. And what this gives us is, in our unit test, now we have to inject the clock, and we'll just create a clock as a fixed time. As you can see, Java defines several useful clocks. We will choose this one, which will always return the same instant. And let's say that we want the clock to always be set to the 1st of January at 12 o'clock in the zone UTC. And by doing this, all calls to the offset datetime now that use the clock will use this value as the current date. So basically what we can do now in our test is to get rid of this is after and is before, and now we can just simply check for equality against an offset date time that is set to this value. And let's check if this test will now pass. And the test passes successfully. We don't need this, we don't need this variable. So by utilizing the built-in clock of Java, we can easily assert the current date and the current time in our unit tests. This concludes today's video. Thank you for watching, and I hope to see you again on my channel. Goodbye.